Today we will learn about exponents. For any natural number a, x to the power of a is defined as x times x times x, a times. So let's write the following expressions without using exponents. 2x to the power of 4. So from the definition we know that x to the power of 4 is x times x times x times x 4 times. So this is equal to 2 times x times x times x times x. What about minus 4x in parentheses cube? Well, this is minus 4x multiplied by itself 3 times. And since our multiplication is commutative, we can swap the minus 4 and the x's so that we can group the minus 4's on one side and the x's on the other side. And this is equal to minus 64 times x times x times x. Using this definition, we can show that if a and b are natural numbers, then x to the power of a times x to the power of b is x to the power of a plus b. That is, if the base is the same, we simply add the exponents. X to the power of a, the power of b is x to the power of a times b. xy to the power of a is x to the power of a, y to the power of a. And lastly, x divided by y to the power of a is x to the power of a divided by y to the power of a. And since division by 0 is undefined, we add the condition that y is different from 0. So let's prove it. X to the power of a, x to the power of b, from the definition, is multiplying x to itself a times and multiplying by the product of multiplying x by itself b times. So in total we have multiplied x a plus b times, and this, using the definition, is x to the power of a plus b. X to the power of a, the power of b, is multiplying x to the power of a b times. And now we can use the first result, which says if the base is the same, we simply add the exponents. So we add the a's together, so we have x to the power of a plus a, and since we have b factors of x to the power of a, we add a to itself b times, which gives us x to the power of ab. And the third one, xy to the power of a, is multiplying xy to itself a times, and just like we used in the second example, we use the commutative property of multiplication, and we group the x's and the y's together. So we have a factors of x and a factors of y. So using the definition, this is equal to x to the power of a times y to the power of a. And lastly, x divided by y to the power of a is multiplying x divided by y a times. And now let's multiply the x's in the numerator together and the y's in the denominator together. So we have a factors of x and b a factors of y. So using the definition, this is equal to x to the power of a divided by y to the power of a. So let's use these results and simplify the following expressions. Y to the power of 4x squared y squared. First, let's use the commutative property and swap x squared and y to the power of 4. Now we can use the first rule, which says if the base is the same, we simply add the exponents. So this is equal to x squared y to the power of 4 plus 2, which is x squared y to the power of 6. Another example, y to the power of 4 to the power of 2. Well, we can use the second rule, which says x to the power of a, the power of b is x to the power of ab. So this is equal to y to the power of 4 times 2, which is y to the power of 8. Third example, x cubed divided by y squared z to the power of 3. So we can apply the 4's rule first. So this is x cubed to the power of 3 divided by y squared z to the power of 3. Now we can apply the third rule to the denominator, and we have x cubed to the power of 3 divided by y squared to the power of 3 times z. Z is also z to the power of 1, so we have z to the power of 1 to the power of 3. Now we can apply the second rule, which says x to the power of a, the power of b is x to the power of ab. So we have x the power of 3 times 3 divided by y to the power of 2 times 3 times z to the power of 3 times 1, which gives us x to the power of 9 divided by y to the power of 6, z to the power of 3. So to proceed, we need one more definition. So a negative exponent is defined such that x to the power of minus a is 1 over x to the power of a, and its counterpart 1 over x to the power of minus a is x to the power of a. So using that, we can show that if a and b are integers, then x to the power of a divided by x to the power of b is x to the power of a minus b. And since division by 0 is undefined, we add the condition that x is different from 0. And this says that if the base is the same, we simply subtract the exponents. So let's prove it. First, x to the power of a divided by x to the power of b is the same as x to the power of a times 1 over x to the power of b. But from the definition of negative exponents, this is equal to x to the power of a times x to the power of minus b. But we know that if the base is the same, we simply add the exponents. So this is x to the power of a plus minus b, which is x to the power of a minus b. And using this, let's simplify the following expressions. So x squared divided by x to the power of 5, well, the base is the same, so we simply subtract the exponents. This is x to the power of 2 minus 5, which is x to the power of minus 3. Now we can also use the definition of negative exponents. This is 1 over x cubed. Another example, m squared m to the power of minus 3 divided by m to the power of 4 times m to the power of minus 6. First, we apply the rule that if the base is the same, we add the exponents. So we have m to the power of 2 plus minus 3 divided by m to the power of 4 plus minus 6. So this gives us m to the power of minus 1 divided by m to the power of minus 2. And now we apply the rule that if the base is the same and we're dividing two expressions, we subtract their exponents. So we have m to the power of minus 1 minus minus 2, which is m to the power of minus 1 plus 2, which gives us m. And a third example, r to the power of minus 5 n cubed divided by r to the power of 5 n to the power of minus 2 cubed. First, we apply the rule that x divided by y to the power of a is x to the power of a divided by y to the power of a. So this is equal to r to the power of minus 5 n cubed to the power of 3 divided by r to the power of 5 n to the power of minus 2 cubed. Now we can apply the rule that x y to the power of a is x to the power of a y to the power of a. And this is equal to r to the power of minus 5 to the power of 3 n cubed to the power of 3 divided by r to the power of 5 to the power of 3 times n to the power of minus 2 to the power of 3. Now we can apply the rule that x to the power of a to the power of b is x to the power of a times b. And this gives us r to the power of minus 15 n to the power of 9 divided by r to the power of 15 times n to the power of minus 6. Then we can use the rule that if the base is the same, we subtract the exponents. So that is r to the power of minus 15 minus 15 times n to the power of 9 minus minus 6, which gives us r to the power of minus 30 times n to the power of 15. And using the definition of negative exponents, this is equal to n to the power of 15 times divided by r to the power of 30. So I hope you enjoyed the video. Thank you.